we have f of x square equals x square and absolute value of cos pi by x when x is not equal to 0, and when x equal to 0, the function is 0. Now, where is it differentiable? At x equal to 0 and x equal to 2, between these two, where it is differentiable or not differentiable. Right. Now, firstly, let us take the easier one, which is at x equal to 2. At x equal to 2, x square is always continuous, and cos pi by x, this is equal to cos pi by 2, this is also continuous. So basically these two functions are definitely continuous. Right. Now, if you see cos pi by x, let us see how does this graph look like and around x equal to 2. When x cos theta, how does it look? Cos theta will look something like this. And this point is pi by 2. Right. This point is pi by 2. This point is lesser than pi by 2. This point is slightly greater than pi by 2. Right. This point is lesser than pi by 2. When lesser than pi by 2, between 0 and pi by 2, cos theta is positive. Between after pi by 2, immediately after pi by 2, it starts becoming negative. Now, here, let's say cos pi by 2.1 or 2 point something, 2 plus something. Right. So, when x is greater than 2, right, then pi by x is lesser than pi by 2. Right. For example, pi by 2.1 is less than pi by 2. That means cos of pi by x is positive. Right. Similarly, when x is less than 2, cos pi by x is negative. Right. So what we are saying, cos pi by x, if this point is 2, then it looks something like this. When x is greater than 2, it is positive. When x is less than 2, it is negative. Right. Cos pi by x. Because we know cos x, cos theta, when theta is less than pi by 2, it is slightly less than pi by 2, it is negative, and slightly greater than pi by 2, it is positive. Now here talking about x in the denominator. That's why when x is greater, then pi by x would be smaller. Right. Pi by 2.1 is smaller than pi by 2, and pi by 1.9 is greater than pi by 2. Right. So when x is greater than 2, it is positive. When x is less than 2, it is negative. And obviously this is a smooth function here. Now when we are putting absolute value of cos pi by x, again at this point, here the graph is actually smooth graph. When you are putting absolute value, what will happen? Whatever is there below the x-axis will just get flipped. Right. The graph which was originally like some curve like this, it is getting flipped, and this part is getting erased. Right. So we are getting a graph something like this. Now suddenly this curve, the slope, whatever at this point, if the slope was 2, suddenly one side the slope is remaining 2, another side the slope is becoming minus 2. Right. If the slope was 1, whatever is the slope, it doesn't matter. There was some slope. Definitely this curve is not flat, like not parallel to x-axis. Right. The slope is not 0. When x is greater than 2, it is becoming positive cos pi by x. When x is less than 2, it is negative. So anyway, the curve is smooth. And suddenly at 2, if you are putting an absolute value, the curve is just flipping, and the slopes are actually changing in the opposite directions. Right. So obviously at this point, it will not become differentiable. Right. And you are multiplying this with some x square. X square is some continuous function like this. Right. Very smooth continuous function. Now you are multiplying a graph with some straight line. Obviously this graph will go slightly upwards like this, but still this corner will still remain. Right. You are multiplying a graph something like this with some straight line or with some curved line. Doesn't matter. It will this corner will still remain. So definitely at x equal to 2, it is not differentiable. Right. So this is wrong. Differentiable at 2, this is also wrong. Okay, it is not differentiable at 2 because of this absolute function, we are creating a corner here where the slope, which was slope was normal, we are breaking the slope. Okay, now coming back to x equal to 0. X equal to 0, x equal to 0. Now let us use our original definition of derivative. What is our original derivative or definition of derivative? F of x plus h minus or x naught plus h minus f of x naught by h, right, limit right, this limit h tends to 0, right. So basically at a point, let's say this is a curve, this point is x naught, and this point is x naught plus h, x naught plus h, then y2 minus y1, which is f of x naught plus h minus f of x naught, by x2 minus x1, which is x naught plus h minus x naught, which is nothing but h. And this h should get smaller and smaller. So limit h tends to 0, this one. Now, in this one, let us try to substitute this one. Right. F of x naught is nothing but f of x naught plus h means f of 0 plus h. Right. X naught is 0 here. We are talking about 0. 2 is already done. F of 0 plus h. 0 plus is anyway h. So this is nothing but f of h. F of h minus f of h minus f of 0. F of 0 at x equal to 0, it is already given. So f of x naught is actually 0. Right. F of 0 is actually 0. It is already given. F of h by h. We are talking about f of h by h when h tends to 0. Right. Now, f of h, what is h? H square cos pi by h by h. We cancel this and cancel this, we'll be left with h cos pi by h. Okay, this limit is h tends to 0, h cos pi by h. Right. Now we know cos pi by h, whatever it is, cos pi by h. Whatever is the cos pi by h, it will always lie between 0 and 1. Now, h cos pi by h is some number. Cos pi by h is always some number lying between 0 and 1. So, sorry, this is f of h is absolute value of cos pi by h. There is an absolute value also. Cos pi by h is some number which is always between 0 and 1 only. It is not even like this. It is something like this. Because if it is without absolute value, it would have run between 1 and minus 1. But now with the absolute value, it is running between 0 and 1. Now some number lesser than 1, greater than 0 or less than or equal to greater than or equal to 0 is multiplied with h. So this product will always be lesser than this h. Right. H into this thing. And so this one will look like something like this probably. Right. And this product will always be lesser than h, whatever is the h. Right. Cos pi by h is a number lesser than 1. So this and this will always be lesser than h. Right. So similarly, this side also. So by using our sandwich theorem, this product is always lesser than these two lines, which are y equal to x, y equal to minus x. At the same time, it is between this x-axis and these two lines. So obviously this one and this one, the limit is actually 0. X-axis is also 0. So that's why this limit h tends to 0 plus or 0 minus, both are actually equal to 0. Right. We use the same methodology in our x sine 1 by x case. Right. X sine 1 by x, we proved the limit exists using our sandwich theorem. Here we are using the same logic. Right. So this graph will lie between this line and this line and this line and this line. So, and this line and this line, y equal to x minus x, this one, these are all, they are converging to 0. Right. Right, their limits are 0 when x equal to 0. Obviously, because of the sandwich theorem, because this is always lying between these two ones, the limit of this one is also 0. So what does that mean? It is differentiable. Limit of this means, what is this limit? Limit is actually the derivative of this, right? F of h by h is actually the slope of this, right? The derivative of this function. So it is differentiable at x equal to 0. So this is the correct answer. It is differentiable at x equal to 0, but not at x equal to 2. Right. So if you look at these graphs, this is cos 1 by x. Okay, like we discussed, just after 2, it is positive, and just before 2, it is negative. Right. Sorry, this is cos pi by x, not 1 by x. Pi by x. So cos pi by 2, cos pi by 2 is 0. At 2 it is 0. Right. Cos pi by 2.1. Right. This is positive, and cos pi by 1.9. pi by 2.1 is lesser than pi by 2, right? Is lesser than pi by 2.1 is lesser than pi by 2. So that's why it is positive. So this graph will look like something like this. Now this is the same graph which is absolute value of cos pi by x. Right, absolute value means whatever is the bottom, whatever this part, it will just get flipped opposite side. So this part, whatever is there, it is just getting flipped on the opposite side. What does that mean? This slope, whatever was there, this is just getting broken and and is getting created like this. So here we are creating a corner here. One side slope is different, another side slope is different. So that is why this function is not differentiable at 2, and for the other case at 0. At 0, when you put an x square thing in between, so then the graph will, whatever this fluctuation, that fluctuation will slow down, slow down, slow down, and it will become something like this probably. Right. So, and at x equal to 0, it is clearly differentiable because we have already proved with the sandwich theorem, x sin 1 by x, x cos 1 by x. These are all same method. We proved it. Right, guys? Thank you.